Hey, welcome back. Today we're jumping into something that is completely shaking up software development, AI-assisted coding. It's fast, it's powerful, and it is changing how we build, well, pretty much everything. But you know what they say, with great speed comes great responsibility. So let's run a little vibe check on vibe coding itself. Yeah, this whole trend actually has a name, vibe coding. You get an idea, you throw it at an AI in just plain English, and bam, out comes functional code. It's all about going from a concept to a real thing at a crazy pace. It lets developers focus on the vibe of what they're building instead of getting stuck in the weeds. But here's the question. What happens when that vibe is, super insecure? And that, right there, is the heart of the problem. All the convenience of vibe coding can actually hide some really serious security risks. According to the AI Red team over at Databricks, these little AI-generated snippets can have dangerous flaws hiding in plain sight, mostly because the code looks like it works just fine. So let's dive headfirst into this dilemma. How can code that seems to work perfectly actually be a ticking time bomb? We're going to walk through a couple of real-world examples that show you exactly how this can happen. Okay, so check this out. Here's our first example. AI-generated code for a simple little snake game. Now, to send data between the players, it uses this common Python module called pickle. And yeah, functionally it works great. The problem? Well, the pickle module is famously insecure if you're getting data from a source you don't trust. A bad actor could send a specially crafted data packet that literally executes code on another player's computer. That is a massive vulnerability. It's called remote code execution, or RCE, and it's just hiding out in what looks like a harmless game. All right, here's a bit more of a technical one. Databricks asked an AI to write a C++ parser for a pretty complex binary file. And just like before, the code it spit out seems to work perfectly. It parses the files, no problem. But if you look closer, the code doesn't actually check the size of the data it's reading. This creates a huge risk of memory corruption, specifically something called a heap overflow. An attacker could create a malicious file that tricks the program into writing data outside of its assigned memory space, which could crash the whole thing, or, even worse, let them take complete control of it. So what this really proves is that you just can't blindly trust AI-generated code. And that brings us to our very first and probably most important layer of defense, the developer. Personal accountability is, without a doubt, the foundation of secure vibe coding. As a developer, you really are the final gatekeeper here. It's on you to review every single line of AI-generated code and to really truly understand what it's doing. This means you gotta validate user inputs to stop attacks, store things like API keys securely, not hard-coded in the script, and even learn how to prompt the AI to give you more secure code from the get-go. At the end of the day, the AI doesn't feel responsible for the code it writes, you have to. Now here is a classic mistake that AI makes all the time. The code on the left, it directly plugs user input into a database query. This basically just throws the door wide open for something called SQL injection, an attack where a user can totally manipulate your database. But a quick human review catches this instantly. And the fix is simple. Use parameterized queries. They safely separate the command from the user's data. It is a tiny change with a massive, massive security impact. So how can you get the AI to actually help you with all this? Well, Databricks found this amazing technique they call self-reflection. It's a super simple three-step process. First, you get the AI to generate the code. Then, step 2, you copy that exact same code and feed it right back in. And finally, step 3, you prompt it with something like, hey, can you review this code, find any security vulnerabilities, and then fix them? It's kind of like asking the AI to check its own homework, and it's been shown to seriously reduce the amount of insecure code it generates. Human review is absolutely essential, but let's be real, it doesn't scale perfectly. And that's why the next layer of defense is all about building an automated safety net. We need tools that can basically be a tireless security guard for our entire development process. One of the most important tools for this is SAST, or Static Application Security Testing. The best way to think about this is like an automated code reviewer. It scans your application's source code, the raw blueprint, and it looks for known vulnerability patterns, like that SQL injection flaw we just talked about, long before the code ever gets run. Now, the other side of that coin is DAST, or Dynamic Application Security Testing. So if SAST is checking the blueprint, DAST is basically crash testing the finished car. It pokes and prods your run-in application from the outside, simulating real-world attacks to find vulnerabilities that you'd only see when the system is actually live and operating. But here's the thing, for these tools to really work,
You can't just use them for a one-off scan. They need to be woven right into the fabric of your development lifecycle. We're talking about running them directly in the developer's code editor, making them a mandatory step in your automated build pipelines, and having them perform one final check before anything gets deployed. It's all about creating this continuous automated oversight. But even the best tools on the planet are totally useless if people just ignore them. And this brings us to the next, much broader layer of responsibility, building a true culture of security. This isn't just one person's job. It has to be a shared mindset across the entire team, the entire organization. A strong security culture, it always starts at the top. You need leadership making it crystal clear that security is a core business priority, not some afterthought. And that means investing in regular training for developers. It means making peer reviews a mandatory step for every single code change. And, critically, it means creating an environment where people feel safe to report vulnerabilities without any fear of blame. It's about making security a team sport. Okay, so we've covered the individual coder, and we've covered the team. Let's zoom out to the final and broadest layer and see how all of this builds into an industry-wide shift. See, the responsibility doesn't just stop with the people building an application. It extends all the way to the companies creating the software and AI tools themselves. A recent report from CISA and its global partners introduces two really powerful ideas for this. The first is secure by design. This means security isn't just a feature you tack on later. It's a core business goal from the very, very beginning, before anyone writes a single line of code. The second is secure by default. This means products should ship in their most secure configuration right out of the box, with no extra fees or complicated setup for the customer. And just so we're clear, this isn't some niche idea. It's a philosophy that's backed by a really powerful global consensus. This whole push is co-signed by agencies from all over the world, including the U.S. National Security Agency, the FBI, the U.K.'s National Cybersecurity Center, and the Australian Cybersecurity Center, just to name a few. The message here is loud and clear. The industry as a whole has to take more ownership of security. So let's just put it all together. This table sums up those expanding circles of responsibility we've been talking about. It all starts with the individual coder, whose key action is that diligent code review and secure prompting. Then it expands out to the team and the process, which relies on automated tools and a strong security culture. And finally, it all culminates at the industry level with that big push for a secure by default future. And that brings us to the ultimate takeaway. For way too long, the burden of security, all the patching, configuring, and cleaning up after breaches, it's all fallen on the end user. This new paradigm insists that this responsibility has to be shared by everyone who creates and sells technology, from the junior developer all the way up to the CEO. So we're going to end with this question. Vibe coding and generative AI, they're not going anywhere, and they're going to build more and more of our digital world. As that happens, the question of who is ultimately responsible for making all of it safe and secure, well, that becomes one of the most important questions of our time. Thanks for joining us.